Hi everybody, today we're going to learn how to balance redox reactions. This is actually one of my favorite things to do. I kind of do it as a puzzle for fun. Balancing a redox reaction is a little bit different from balancing our regular molecular reactions that we've been balancing all year, because usually when we balance reactions we care about the law of conservation of mass, so we make sure that the number of atoms and the types of atoms on both sides of the equation are equal. With redox reactions, because it involves the flow of electrons, we not only have to balance mass, which means the atoms, but also the charge. So there are many ways that you can balance redox reactions. I think this is the easiest method to do it, and it's called the half reaction method. And it's called half reaction because basically you split the reaction into two, balance them separately, and then put it back together. So as you can see, it has a lot of steps. There's 9 steps. Really, there are 7 essential steps, 2 through 8, but doing 1 and 9 are useful. So I would recommend doing all 9 steps. Don't worry about how long it looks. It does take a while, but if you are careful and if you do it slow and do every single step, you will always get the correct answer. And if you get the wrong answer, you will know that you got it wrong so that you can go back and check it. We will give you these rules on the test, so you do not have to memorize them. You just have to be able to read them and apply them. So we'll start with 1, and we'll go through the rules as we go through it. So let's start with the first one here. So it says Ca plus N2 yields Ca2 plus N3 minus. Let's look at the first rule. So the first step says identify the oxidation numbers of all species, then decide which ones have changed, which ones were oxidized, which one reduced. So we've done this before. So we're going to assign the oxidation states. So for calcium, this would be a 0. And for nitrogen, that would be a 0. For the Ca2 plus, it's a +2. And for the nitrogen 3 minus, it's a -3. Okay, so it looks like the calcium changed. It went from 0 to +2, so that was oxidized. And the nitrogen also changed from 0 to -3, so that was reduced. Okay, let's look at step 2. Step 2 says split the reaction into the oxidation and reduction half reactions. So let's do that. So we're going to have calcium going to Ca2+. That is our oxidation half reaction. And then we have N2 going to N3 minus, and that is the reduction half reaction. So we're already done with 2 steps. Now, to be honest with you, you actually don't have to do step 1 in order to balance the chemical reaction. You need to know how to assign oxidation states. You need to be able to know what's oxidized and what's reduced, but you don't have to do it in order to balance a chemical reaction. So if you are just looking to balance it, you can start with step 2 directly, because you can probably figure out how to split it up without knowing which one's changed. If you look at the reaction, you probably would be able to tell that the calcium would go with the calcium and the nitrogen would go with the nitrogen. So really, you can kind of skip step 1. Anyway, we did step 1 and step 2. Let's look at step 3. Step 3 says balance all the atoms that are not oxygen or hydrogen first. So we don't care about oxygen or hydrogen. We're just going to balance everything else. So let's do that. And so calcium, we have 1 and 1, so that's already balanced. The nitrogen, we have 2 and 1, so that's not good. So we need to fix that. And so we put a 2 right here so that it's balanced. All right, step 4. Step 4 says balance the oxygen and hydrogen atoms using the following rules. Well, no oxygens or hydrogens, no oxygens or hydrogens, so we're done with that step. Okay, step 5 says balance the charge by adding electrons. So we're going to start with the calcium. So the way that you do that is you figure out the charge here. So this has a charge of 0. This side has a charge of +2. Now electrons are negative, and we're trying to make those two sides equal to each other. So you always add the electrons to the more positive side. So between those two, this side is more positive, so that's where you add your electrons. And in this case, we would need 2 electrons so that we can balance it, because then that would be +2, this would be a -2 for a total of 0 there. Okay? Let's look at the other side. So here we have, this has a total charge of 0 on that side. This has a -6 because we have 2 of the 3 minuses. So you add the electrons to the more positive side. So in this case, it would be this side, as 0 is more positive than a -6. And so you would need 6 electrons on this side. Now, if you do this correctly, you should always add the electrons to different sides of the two equations. What that means is for one of them, the electrons will be on the products. For the other one, it will be the electrons. If you figured out which one's oxidation, which one's reduction, the oxidation means loss of electrons, so for oxidation, it's always going to be on the product side. Reduction is gain of electrons, so it's always going to be in the reactant side. But, even if you didn't assign oxidation or reduction, you should always have one in the products, one in the reactants. If you are adding the electrons in both reactions to the reactants or both to the products, that means you've done something wrong, so go back and check your work. The next step, step 6, says, if necessary, multiply one or both balanced half reactions by an integer to equalize the number of electrons transferred in the two half reactions. So what that's saying is we want the number of electrons here and here to be equal to each other. And you do that by multiplying either one reaction or both reactions by an integer so that those numbers are equal. And so in this case, we have 2 electrons, 6 electrons, so you would want to multiply this reaction by 3. So this reaction is going to be multiplied by 3. So let's rewrite it multiplied. So you'd have 3Ca yields 3Ca2 plus 6 electrons. Now, why is it that we want the electrons to be equal? Well, because it's a redox reaction. That means we have transfer of electrons. One substance is losing electrons, the other one is gaining those electrons. So they're the same electrons that are being lost by one, gained by the other. They're being transferred from one substance to the other, so they need to be the same number. Okay, next step, step 7 says, add the two reactions together and cancel any like terms on both sides of the equation. So what that means is we're going to add the two of them together, meaning that the reactants for both equations are going to be on the reactant side. We're going to write them all. Then we're going to write an arrow. And then we're going to write the products all together. So let's try to do that. So we would have 3Ca from here plus 6 electrons plus N2 yields 3Ca2 plus 6 electrons plus 2N3 minus. If you did this correctly, your electrons should always cancel out. You have 6 electrons here and 6 electrons there, so they cancel out. because they're being transferred. They're lost by one and gained by the other. So let's rewrite that to make it look neater. So 3Ca plus N2 yields 3Ca2 plus 2N3 minus. Step 8 says if basic, well, doesn't say anything about it being basic. It will tell you if it is basic. So since it doesn't tell you, we can skip that step. And step 9 says check to make sure mass and charge are balanced. So we're done balancing it. We just need to check that it's correct. And so normally we would check the mass, which means we check the atoms. So we would check the calcium and we would check the nitrogen. But because it's redox, we also check the charge. So let's look at the calcium. We have 3 and 3, so that checks. The nitrogen, we have 2 and 2, so that checks. The charge, this is neutral for a total of 0, or neutral. This is plus 6, this is minus 6 for a total of 0, or neutral, so they match. So that means it is correct. So this is your balanced equation. All right, let's do one that's a little bit more fun now. All right, let's try this one. It says MnO4 minus plus Fe2 plus yields Fe3 plus Mn2 plus, and it says it's in an acidic solution. So the first step is to assign oxidation states to all species and see which ones they've changed. So you don't really have to do that, but let's just do it. It looks like we have the oxidation states for this one is plus 2, this one's plus 3, this one's plus 2. The only one that we don't know is those manganese and oxygens because that's an overall charge for the whole thing. So we know that oxygen is -2 in compounds. So if you solve for the manganese, that makes it plus 7. If you guys remember the demo we did at the beginning of the year with the grape Kool-Aid, where I turned the grape Kool-Aid or the grape juice into water, it turns out that manganese, when it's a plus 7, is purple in color. When it's a plus 2, it's colorless. So what I did was I took some potassium permanganate, which is KMnO4. So that's K plus and MnO4 minus. So it had MnO4 minus, which was purple in color, and I used a reducing agent to reduce the manganese from a plus 7 to turn it into a plus 2. So it turned colorless, it looked like water. Now to make it into milk, I just added a substance that makes it precipitate, and so the precipitate was white and it looked cloudy like milk. All right, so we did step 1. It looks like the manganese was reduced from plus 7 to plus 2. The iron was oxidized from plus 2 to plus 3. Second step says to split the reaction into 2 reactions, so the oxidation and then the reduction. You didn't really have to do step 1 in order to do that. You could figure out that the MnO4 minus would go with the Mn2 plus, and then in the other reaction, the Fe2 plus goes with the Fe3 plus. So we did step 2. Step 3 says balance all the atoms that are not oxygen or hydrogen. So we have 1 manganese, that one's good. Here we have 1 Fe, 1 Fe, so that's good. Step 4 says balance the oxygens and hydrogens using the following rules. And you have to do this in order. So 4A says you balance the oxygens, each oxygen, by adding water to the deficient side. So let's look here. We have 4 oxygens. We don't have any on this side. So for each oxygen that's missing, you add a water to the deficient side. So that means we need to add 4 H2O. Okay, on the other side, we have Fe2 plus and Fe3 plus. No oxygens here, so we don't need to do 4A for that one. Okay, 4B says balance the hydrogens by adding an H plus to the deficient side. For each hydrogen, you add an H plus to the deficient side. So here we don't have any hydrogens. Here we have 4 times 2 is 8. So on this side, we're going to add 8 H plus. Make sure it's H plus, not H or H2. Here we don't have any hydrogens, so we don't have to worry about that. Now you have to do it in that order because when you balance the oxygens, you're adding waters, which changes the hydrogens. So that's why you have to do A before B. You have to do the oxygens first, then the hydrogens. I've been pestering you all year about, can't create matter, you can't destroy matter. And so how come we're just randomly adding waters and H pluses? How is this possible? Are these just, coming out of nowhere? Well, of course not. This is an acidic solution. You remember what an acidic solution means? That means you have water, it's an aqueous solution, and acid means that you have extra H pluses in water. So an acidic solution means you have extra H pluses and you have water. So those particles can participate in the reaction. That's why we're allowed to use them when we're balancing the chemical equations there, the redox equations. All right, we're done with step 4. Now step 5 says balance the charge by adding electrons. Let's do the easy one first. Let's do the one with the iron first. It looks a lot simpler, so I always choose to do that one first. I have on this side +2, on this side +3. So I add my electrons to the more positive side. And so that means I'm going to add my electrons to this side, and I only need 1 electron in that case. Okay, let's look at the other one. Now the reason why I do the easy one first is this one I can figure out pretty easy. And I know now that I have added this one to the product side. So that tells me that in this one, I'm going to have to add it to the reactant side. So if I figure it out and it turns out that it's here, I know that I've made a mistake and I can fix that. So let's try to figure this one out. So we have 8 H pluses, so that's a total of +8 because each H plus is +1, and there's 8 of them. This one's a -1 for a total of +7 here. On the product side, this is a +2. This is neutral for a total of +2. So I add my electrons to the more positive side, so that would be to the +7. And so I would need 5 electrons on this side. So that one was a lot harder than the first one, so that's why I do the easier one first. All right, done with step 5. Now step 6 says, if necessary, multiply one or both half reactions by an integer to equalize the number of electrons. So I want this number of electrons to be equal to this number of electrons. So we have 5 and 1, so that means I would want to multiply this reaction by 5. So that would give me 5 Fe2 plus yields 5 Fe3 plus 5 electrons. Step 7 says to add my half reactions together and cancel any like terms. So that means I'm going to add all my reactants together. Then I'm going to put an arrow, and then I'm going to do all my products together. So let's do that. Do it in different colors so it's easier to see. So 5 electrons plus 8 H plus MnO4 minus plus 5 Fe2 plus yields Mn2 plus 4 H2O plus 5 Fe3 plus 5 electrons. If you did it correctly, your electrons should always cancel. Sometimes other things cancel, like your H pluses or your H2Os, but not in this case. So then just rewrite it so it looks neater. So 8 H plus MnO4 minus plus 5 Fe2 plus yields Mn2 plus 4 H2O plus 5 Fe3 plus. All right, step 8 says, if basic, well, it tells us it's acidic, so we know it's not basic for sure, so you do not need to do step 8. Step 9 says check that the mass and the charge are balanced, so let's do that. So we have some hydrogens, we have manganese, we have oxygen, we have Fe, and then we also have the charge. So these are all the things that we need to check. So let's start with hydrogen. So we have 8 hydrogens here. On this side we have 4 times 2, that's 8. So that one checks. Manganese, we have 1 and 1, so that one checks. Oxygens, we have 4 and 4, so that one checks. The iron, we have 5 and 5. That one checks. Let's look at the charge. So this is a plus 8, this is a minus 1, and this is a plus 10, for a total on that side of plus 17. On the product side, this is a plus 2, this is neutral, this is a plus 15, for a total of plus 17. So they match. That means this is the correct balanced equation. Let's try one more. Okay, this one says AlH4 minus plus H2CO yields Al3 plus CH3OH. And that one is in a basic solution, so we finally get to do step 8. So step 1 says to assign all the oxidation states and see which ones have changed. Again, you don't really have to do that, but you can if you want to. So I'll do it in case you want to do it and check. The aluminum is plus 3. The hydrogen, because it's in a hydride, is a minus 1. The hydrogen in the H2CO is a plus 1. The oxygen is a negative 2, which makes the carbon 0. On the other side, the aluminum is plus 3. It's given to you there. The hydrogens are each plus 1. The oxygen is negative 2, which makes your carbon a negative 2. So the ones that have changed are your carbon. It went from 0 to minus 2, so that was reduced. What was oxidized was actually these hydrogens here, not those, but these. They went from negative 1 to plus 1, because all of the ones in the products are plus 1. These are minus 1, these are plus 1. So those ones didn't change, they're still plus 1, but these changed from negative 1 to plus 1, which means they were oxidized. Again, you do not need to do step 1 in order to balance. So let's do step 2. Step 2 says to split up your reaction into the 2 half reactions. So you can tell that the AlH4 minus will go with the Al3 plus. And then on the other one, it'll be H2CO yields CH3OH. Okay, step 3 says balance all atoms that are not oxygen or hydrogen. So we have 1 aluminum, 1 carbon, 1 carbon, so that one's good. Next, step 4, 4a says to balance the oxygens using water. And so no oxygens here. Here we have 1 and 1, so that one's good. 4b says balance the hydrogens using H pluses. So this one has 4 hydrogens. This one doesn't have any, so we need 4 H pluses on this side. The other one, we have 2 hydrogens here. We have 4 here. So we would need 2 H pluses on this side. All right, step 5 says balance your charge using electrons. So let's look at our charge here. In this one, this is a -1. On this one, this is a +3, and that's a +4 for a total of +7. So remember, you want to add it to the more positive side, which is the +7, and you'd need 8 electrons in order to make it equal to the other one, to the other side. Okay, let's look at the other reaction. We have 2 H pluses for a total of +2 and 0. So that side's total is +2. This is neutral, and so that means we would want to add it to the more positive side, to this side, and we'd need 2 electrons. So I'm going to add 2 electrons to this. All right. Step 6 says, if necessary, multiply one or both half reactions by an integer to equalize the number of electrons. So here we have 8 electrons. On this side we have 2 electrons, so we want to make them equal, so that means we want to multiply this one by 4. So I'll take this whole thing and multiply by 4. So I'll rewrite it, so that would be 8H plus 8 electrons plus 4 H2 CO yields 4 CH3 OH. Okay, step 7 says add both half reactions together and cancel any like terms. So that means add your reactants together, then an arrow, and then add your products. So let's do that. So we have AlH4 minus plus 8H plus 8 electrons plus 4 H2CO yields Al3 plus 4H plus 8 electrons plus 4 CH3OH. Cancel any like terms. If you did it correctly, your electrons should always cancel. Something else cancels here. We have 8 H pluses here. We only have 4 H pluses there, but since we have some H pluses on both sides, we can cancel some of them. We can cancel 4 of them. So I can cancel these 4 with 4 of these, so we'd be left with 4 of them. So let's rewrite that neatly. So AlH4 minus plus 4H plus 4H2CO yields Al3 plus 4 CH3OH. All right, finally we get to use step 8. Step 8 says if basic, and it is basic, you add an OH minus to both sides for each H plus. So we have some H pluses there. You can't have extra H pluses in a basic solution because H pluses means it's an acid, right? So if you have any H pluses in a basic solution. Like if you had an acid to a base, they react together. The hydroxide and the base reacts with the H plus and the acid, and they form water. So if it's a basic solution, that means you have a lot of OH minuses, not H pluses. So what this is saying is for every H plus, you add an OH minus. So here we have 4 H pluses, so you add 4 OH minuses. So I'm going to add to this 4 OH minuses. Problem is, we just spent like 5 minutes, or maybe more even, balancing this reaction so far. And if I just add OH minuses here to the side, then I've changed the charge and I've changed the mass. I've just added a whole bunch when it was theoretically already balanced. And so that's a problem. And so that's why, if you read step 8 again, it says, add OH minus to both sides of the equation for every H plus. So that means if I add 4 OH minuses to the reactant side, I also add it to the product side. So it's on both sides. Now what happens is H pluses and OH minuses combine to form water. So you cross those out, and instead of these, you write 4 H2Os. Okay, so let's rewrite that. AlH4 minus plus 4 H2O plus 4 H2CO yields Al3 plus 4 CH3OH plus 4 OH minus. Now sometimes, just so you know, when you do combine these to make water, sometimes there's other waters on the side. You just add them together. So like if there was another 1 water here, then this would be 5 H2Os. Or if there was water on this side, then you can cancel those out with the waters that are here, if that happens. All right, we're done with step 8. So step 9, it should be balanced. Just check mass and charge. So let's do that together. So let's make a list of the stuff we need to check. We need to check aluminum, we need to check hydrogen, we need to check oxygen, we need to check carbon, and then the charge. Let's start with aluminum. 1 aluminum, 1 aluminum, that checks. Hydrogens, let's see, we have 4 right here. 4 times 2 is 8, and 4 times 2 is 8, for a total of 20 on this side. Here we have 4 times 4 is 16, plus 4, that makes it 20, so the hydrogen checks. Okay, let's move on to the oxygen. So for the oxygen we have 4 here for a total of 8. Right here we have 4 and 4 for a total of 8, so that checks. So the oxygens are good. Let's look at the carbons. The carbons we have 4 and 4, so that one also checks. Now let's look at the charge. This is a -1, 0, and 0 for a total of -1. On this side we have a +3, 0, -4 for a total of -1. So that checks, so that means we've done it correctly, and this is our balanced equation.